Alright everybody, welcome to Hackster. Today we have with us Mingjing Huang, who is an awesome art technologist extraordinaire. What would you call yourself?
Artist, electrical engineer.
Cool.
Yeah, I have a lot of slashes in my title.
So you've done all kinds of stuff everywhere, from working with huge companies like Apple and Nokia and stuff to do intense hardware engineering, all the way to doing, independent stuff for Burning Man, open source stuff with Arduino, and so basically all across the gamut. So what's your favorite thing that you've worked on? Surprised you with that one, sorry.
Yes, you did. Well, I think that it depends on kind of which axis you measure it on. I think some of my favorite projects with the collaborative front has been like at big companies like Apple. Honestly, it feels like that was a part of my career where I got more of a sense of not just kind of like following protocol, but like really what it's like to work with people who care about what they're doing. Yeah, I always think really fondly of like times at Apple where, they introduced like a tool to help the system engineers like organize and collaborate better. That they adapted, I think, SVN or something for that. And unlike other typical like corporate tool releases, they didn't just kind of dump it on us and say like, okay, just now it's your problem, and then it doesn't quite work right. Like they actually had people who would be ready to be on call. We could call them and say like, hey, I'm having this problem, and then they also like improved it over time, so it actually became a really, really useful tool.
Listening to the users?
Yeah, absolutely. Absolutely. And what that sort of like taught me was this idea that tools can be adapted from other areas for hardware use, and this is something that I want to like kind of encourage people to do more on GitHub for hardware projects as well, and of course on your platform, where it isn't just sort of like here's something more standardized, something with more documentation, just so that collaboration is a little easier.
Yeah, because there's so much sort of repetition of work where it could be like if someone's working on something really important, instead of everyone starting it from scratch, you can like easily adapt something that already exists.
Yeah, that's the efficiency monster talking in us, I think. Right? Like, absolutely, yeah. In terms of more, a little bit of a different way of collaborating, I think, has been like the Burning Man project, big Burning Man project, Rainbow Bridge. Everybody. That I did. I think it's a very different mindset because we're working on art. We're working on something that maybe isn't as well resourced. We're working in harsh conditions, so it becomes a lot more personal. But I always really like taking pictures of cable routing under the bridge, because I think everyone else notices like the bright blinking lights, and that's really lovely. But for me, like as an engineer, part of my art is about organizing and designing the system so that it's debuggable and it's clean and it's easy install. And I mean, I push to get some of the pieces in, because obviously you have to spend money on doing it. But when I was installing it, like, to see kind of the way that you design something implemented on a large scale, on something that's like 75 feet wide and 30 feet tall, is like a really different feeling than seeing it implemented on like a computer scale or a wearable scale, right? Like,
right, because you worked at Basis as well, right?
Yeah, that's right.
Cool. So we have some pictures of stuff that you've worked on. You were just talking about the electronics underneath the Rainbow Bridge. Here's the picture of the Rainbow Bridge. This is from after you just finished constructing it?
Yeah, this is Monday afternoon. I would say about 4:30. I remember very clearly because I had about 3 hours of sleep the night before. This was the time when like all of the pixels were working, and I was handing off to Tracy, who's standing in the middle there. You can see the scissor lift that we had behind us. That's sort of like what we worked with. It was my first time working with like construction equipment. So that was really fun. And I'm holding these pair of like wire cutters in my left hand there in the picture. And there's a series of pictures where I'm like, I don't know what to do with these wire cutters. Like, I hope I don't stab myself with them.
Oh yeah, that's ideal.
Yeah.
So wait, these are giant. Are these all panels covered in pixels?
Yeah. So there are a total of 56 panels on the bridge, 28 on each side, and each one have 450 LEDs.
Wow, I think I saw an image back here of an arch that was sort of. This thing, is this that? Because I was like, how is that happening? And then I realized,
that's it.
Oh my god, that's amazing.
That's it.
That looks so sort of sci-fi and fantastical.
Yeah, actually, can I show you one of the pictures that I
Please do.
Really enjoy? It might take a little while to load here. Oh, there we go.
Ooh, oh, it's Pac-Man.
Oh, this doesn't quite. Thanks, Wix.
Ooh, that's really pretty too.
So this was, I think, Tuesday night coming back around sunset, and
it's adorable.
There, the Ghost Car is by Sheldon, also underneath, and I think he did a DJ set. But this was one of my favorite moments of Burning Man last year. Was the crossover, like the ghosts in real life, but also the Pac-Man and Ghost on the Rainbow Ridge. It's just, I don't know, something.
And if this happened for real, wouldn't the ghost die because Pac-Man was like going over to eat him or something?
Yeah, I mean, this was like the angle that it was at, right? Yeah. I don't know, we should have maybe like synchronized it a little bit more too with Sheldon. He could have like changed colors and like, burst into flames or something like that.
You always gotta burst into flames, that's awesome. Down here you have another thing that we were looking at. So this is for a public art installation in San Francisco?
Yeah, that's right. I think it was like late 2017 was when Anti-Clockwise Arts contacted me. They were doing, I think, a series of 50 of them at Civic Center. And they're called Pixel Pulls. And their first iteration, or maybe their second, I'm not sure, the iterations that they had done of the PCB with a Chinese vendor was having a lot of issues with overheating, and they were running out of time, so they asked me to do a board design for them.
I mean, I get the overheating thing because these things have a ton of pixels really close together.
Absolutely, yeah. It was they wanted to get as much light out of it as possible, obviously, and also, quantity-wise, it's not that great, but I think we were kind of locked into the overall thermal solution in the system. So I built this board for them, and I think the biggest part of the thermal was to use more copper on top and bottom, as well as exposing the ground on the bottom so we can attach heatsink to it and allow that to dissipate the heat. In the end, I think it helped a lot that the overall housing was also aluminum, so as long as there was some thermal coupling to the external housing, there was actually a lot of thermal mass to dissipate the heat.
Oh yeah.
Yeah, I love this shot because, I was trying to crank this out for them, and PCB design is very detailed, like deep dive kind of stuff, right, to get everything right.
It's kind of mesmerizing.
I was like, I think had been up for like 16 hours or something like that working on this, because you just have these mental balls that you're juggling, and you're like, I don't want to forget any of it, right? And then I looked at the specific layer. I think this is the top layer. And I thought, oh my goodness, it looks like a mandala.
It totally does.
Yeah.
And then on the bottom you said that kind of looks like the Rebel Alliance logo.
Yeah, right. The way that the solder mask is peeled back to expose the copper sort of looks like the Rebel Alliance logo.
Badass. So with that kind of a shape, do you have to manufacture a heatsink in that shape, or did you just like that was what was exposed, so that's what would touch the heatsink, so you can really just sort of mash it down on top of like a square heatsink or whatever?
Yeah, I think that the mechanical design of the system was already fixed, so we wanted to use as much of the area as possible to put as many LEDs in as possible. This meant that we just had to source a heatsink that was as big as possible, but that would still fit in it. You know, I think at 50 it may have been possible to like mill something out of a bigger heatsink that was perfectly round, but I don't think the project ended up having enough time to do that.
Yeah, that would take a while.
Yeah, so if you're designing from scratch, heatsink is probably the thing that you should take into account, like the shape that you can get off the shelf, and then you can design your board to it. And
did you go with like a square one in the end? Or?
Yeah, I think we ended up with a square one at the end.
Just one that would like fit. Yeah. So yeah, besides all the amazing, oh, you know what? There's one more thing with the art that you were going to talk about, because this has been a big part of your journey as someone who's like working with tech. It's kind of informed your tech progress. Is that true?
Yeah, absolutely. So I have always done like a lot of different types of creative mediums, and this is a kind of painting that I've done, visual art that I've done for over a decade. So this particular painting is not, but two of my paintings done. Yeah, I think it's this one here.
Wow. Can you make that bigger?
Yeah, this one here is called Siren Spring, and another one called Firebirds. These are two of my paintings that are currently on exhibit at the Caltech Gallery. So Caltech is my alma mater.
Oh, cool.
Yeah, they had a call for art by, you know, basically scientists and engineers, everybody who graduated there or is associated with them through Jet Propulsion Laboratories for submission. So.
Really?
Yeah, if you're in Pasadena, you should go check it out, because there's a lot of generative art, but also like fine art in a bunch of different mediums.
Wow, cool. Was the other one the fire one?
Yeah, right. That's the right one.
This is the right one?
Yeah.
Cool. Ooh, wow.
So yeah, so this is like a painting process called process painting. That was a strange sentence, but there it is. That's really about like expressing your internal landscape. I don't really start out thinking I'm gonna paint, you know, a mountain or bird or something like that. It's really about taking a paintbrush, going to the table, picking a color that you feel like that's the right color, and then going to the paper and doing something with the paintbrush, and then evaluating in a constant way, like, you know, does this feel good? Does this feel bad? There's a little Easter egg in this painting, actually, because there's a little IC and in a little tiny PCB. Because,
what? Where?
Yeah. I wonder if you can find it if you zoom in.
Oh my god. I noticed that there's this... Oh, wait, is it over here?
Yeah, that's it.
I'm not going to point it out for our viewers unless you can see the cursor, because you can find it for yourselves. Just search for Mingjing on Redbubble. I also noticed there's the character for fire in the corner there, which seems very thematic.
Oh, yeah, actually, that's my signature.
Oh,
yeah.
Cool. Wait, oh, yeah, it's not exactly the same,
It's not quite the same, but it has that sort of, like, amalgam in it, right?
Yeah, so that's super cool.
Yeah, so I think you were mentioning earlier, like, my creative process has sort of gone in these parallel paths while I was doing engineering work, which is very creative, but also expressing myself in these other mediums. And it feels like in more recent years, they've sort of started to converge a little bit with a lot of the artistic endeavors that I've tried to pursue in other mediums, like informing the way that I think about engineering as well. So that's why it's been a really scary but also exciting time to kind of like explore doing electronics as a part of like sculpture and large format like art.
Cool.
Like with the Rainbow Bridge, right? So you know, it's like I built this particular board. Ooh. This is a 1, 2, 3, you know, like 40, 45 up or something like that panel. And it's a tiny little board that I built because of my work on the Rainbow Bridge, specifically because we needed isolation between the controller and each of the panels of the way that we modularized it.
We'll take some photos of this so we can put it up. That's super cool.
Yeah, it's actually on Tindy, so if it happens to be functionally fits with what you're doing, you can go ahead and buy some. But I think that I really enjoyed kind of the process of, you know, building the system and then realizing, oh, there's a little small functional piece that's missing for us, and I could solve it by building this board. And the time actually like fit what we needed to do, and we used it at Burning Man, so it works. So that's
these ones are not covered in playa dust, but it looks like a new panel.
Yeah, it's a new panel, right? If you want the ones to be covered in playa dust, that I don't know if they're. I think those are still like in storage because we're hoping the Rainbow Bridge. Yeah, we're hoping the Rainbow Bridge will be deployed again somewhere.
Cool.
To bring the magic.
So besides working on, you were doing more consulting and more work with sort of art groups nowadays. And in the past, you've been a senior engineer at large companies where you ended up getting a bunch of patents. And I'm curious about what the process is like for that. Do you just be like, I have to invent this new thing for this, let's go patent it? Does someone like come in and be like, we want to hold on to this as a company? Like, how long does it take? I don't know. I know nothing about this process. I'm really curious.
Yeah. So I think Amazon or Lab 126 was the first company that I was working at that had a lot of strong push for patents. So specifically because so at Cisco and Apple, I was working on things that were sort of like well-defined, like we're making a computer, right? Even when I was working on iPad version 0, there was, you know, sort of cutting-edge technology, but we weren't really trying to make something that was going to be manufacturable in 2 or 3 years. We were trying to make something that was manufacturable now, right? So at Lab 26, the project I was on it was going to be the next one after they, you know, like they wanted to diversify from the Kindle. So there was a lot of exploration. There was a lot of experimentation. I think of like the product development process as like 80-20, because you spend 80% of the effort figuring out where you're going to build, and you spend 20% of the effort building 1 million of it, right? So we were in a slightly different part of the product cycle. So that's why like the lawyers and also like management were very, very encouraging in terms of saying like, pay attention to these ideas that you're having, because we're trying to build prototypes to try out things. And they really made the process really easy for us because they had patent attorneys basically come in and have meetings where like the inventors or the potential inventors would just sit in a room and we would talk about the specific idea. Sometimes we would have a meeting where we would talk about 3 or 4 different ideas. I mean, you can really see how enabling an easier process really helps push things through. I think I had like 3 or 4 patents or more, like at Lab 126. And these are really kind of ideas that come out of just everyday like engineering. Like I think one of the ones that we had was sort of like blue skies. What if you had a device that had a screen in the front and back, and you could interact between them, right? You can have a way of like interacting with the top that would push it to the back, and then you have a way of interacting with the back that would push it up to the front, right? So
it makes me think of like portals.
yeah, absolutely. And I think it was just kind of as simple as that. And then when you just kind of like do like not quite free association, but you sort of like talk about like possible applications. You talk about in these meetings with the patent lawyers, you talk about possible applications. You talk about other ways that this could be implemented. You talk about, for example, power consequences for the device, you know, as much detail in any of the areas as you have the expertise of going into. And then after the meeting, the attorneys take the notes and they go away, and then they like basically write up everything in lawyer speak, and they draw a bunch of diagrams in patent diagram format, which
it's really cool when you look at patent diagrams online. They
they're very specific, right? They have a very specific look to them, and I think that for them, like they do this for a living, so they're like it's a kind of like practiced for them. So
and they probably kind of know what's out there in the landscape already, so you're not sort of over.
That's right. Like you as the inventor, you are not allowed to, you're very highly discouraged to do any kind of searching online.
Really?
Because this is what you don't want to do.
Get stuck in your head.
Because you could like find something and then they can say, well, you actually, you stole this idea from somebody else, right? So they want your brain to be cleared from this kind of influence.
I worry about this so much as a musician, actually, where like you know that you could get something caught in your head and like from 10 years ago, and then you write something. Sometimes I get halfway through a song and I realize, oh shit, that's like some Beatles song or whatever. Oh man! Right. And it's so hard to like get stuff out of your head once it's in there.
Yeah, so that's why the attorneys don't have you do any of that. They do it themselves, and they word it, I think, the language and as well as the drawings to kind of like avoid infringing on any of the patents that they have found.
Cool.
And then they bring it back to you, and then you do another revision of review, and you give comments, and then they change up things. I've gone through several of that at Amazon Lab 126 and also at Nokia and also at Intel. Intel also does a pretty good job of that. Although because it's a bigger company, it has like, I guess its bureaucracy is bigger.
Like they also have some other resources that you've taken advantage of. Like for example, I see there's this test jig you were talking about for debugging. Do you want to show that off?
Oh, I wish this was a better color. So this is a kind of 3D printed pukey green color. So I apologize for that. As an artist, I find the aesthetic slightly offensive, but we're just showing you.
I've heard of dyeing.
Yeah, that's true. We can hold this corner and then we dye it a different color. But this is some of the things that a principle that I learned at Apple, is that when I was at Basis, we were building very tiny little PCBs that had connectors for debug boards that were very delicate. And so I asked one of the mechanical interns to design a system that basically allows us to hold all of the little tiny PCBs in place with screws onto a little platform so that the top and bottoms of the PCBs are accessible and all of the connections are, not under stress. So something like this would be populated with, the form factor board and maybe like the screen here. I think that's what that is, and as well as a debug board on this side. And the firmware engineers or anybody else who's needing to use a board not in the housing could just take this and you can plug a USB thing into it. You can do all sorts of debugging on it without having to like hold it with your hand or like put it on a piece of plastic or cardboard. That's a very popular thing.
Because the stress too can affect the debugging, like
yes, right, and especially in the earlier part of the product development process, you might find something that came out of a build of 50 that failed in a particular way, and you really want to do detailed debugging, so you don't want to introduce like other issues with ESD because you're handling it or because you're needing to reprogram it 50 times with slightly different code each time, and you're not sure if each time you're plugging it in and out of the battery or something like that, it's causing it to like fail in a new way, right? That's the most frustrating thing with hardware debug. So having something like this, which is basically a principle I adapted from the days when I worked at Apple. We call this an acrylic, which is kind of what I wanted to be built out of, which is a piece of acrylic. And it holds your PCB in place in such a way that allows you to access it with an oscilloscope above and below, as well as it being a really nicely carryable platform for firmware development. Right?
That's super cool.
Yeah.
Did you want to talk at all about your newer art piece that you brought here?
Yeah, sure. Okay, so I think that a part of the way that the other art informed me in different mediums, has informed electrical stuff, is sort of this concept of adjacent possible. I think I read this in a book. I don't remember which book it is, but the idea that like we're often sort of we're going one direction for so long that we forget to kind of like turn our heads and look around and see what might be interesting or just fun, right? So this is the project that I built because I was working on a consulting project that used piezoelectric elements in them, and it was really surprising to me how much electricity is actually generated out of a piezo. Huh. So if I go like this, I don't know if you can see it or not.
I'm sure they can hear it, yeah.
Yeah, so this generates a really nice kind of musical shaking.
Oh, you can see it. Oh, wow.
Yeah, but it also like blinks the LEDs.
And there's no
battery.
And no controller.
No controller.
Wait, are these Neopixels? Oh, no, okay. All right, yeah. They're like low power or... Are there even low power ones? They usually like...
No, this is just some... I think these are... These may be 12 volts. Actually, these are 12 volts. Yeah. So they're just like analog strips that I had on hand.
And they'll blink off of that. That's incredible.
And they'll just blink, right? And this is my very first prototype. It's just like things that I had on my hand, right? Like literally a pair of earrings that I got at the Guggenheim came in this little bottle with the cork on top. And the most recent development is actually getting these beads from the bead store in San Francisco, because I honestly started using garbanzo beans because it's cool. Yeah, and
I love it.
And this sort of like inspired me to really think about like electronics or light projects that don't really require battery. And one of my ideas I'm still like yet to implement is to build tiles that would have piezo and also maybe an input and output, so that you can, if you step on a tile, it would like light up the next one. Oh, yeah. I was thinking that you can do it at the beach where you bury everything, but then you would be able to see the light at night.
That's really cool.
Yeah, my optometrist gave me the name. It could be called the Yellow Brick Road.
Oh, yeah. Especially going along with your rainbow bridge. That feels like it's a good sort of pair of things to work together.
Yeah, like the idea of like finding your path, or like, one step at a time, but experimenting. I think a lot of your audience probably, hacks things together for their own passion. And so I just wanted to kind of like show this, because this was something that kind of just came out of like, hey, it might be fun to build this. This is Rev 2. Everything is enclosed inside.
Oh, yeah.
And I think I used UV glue here to like glue everything, and I wanted to make it as thin as possible so you can barely see the electronics, and so it just doesn't feel like it's anything electronic. And this one doesn't work as well actually, because of the way the piezo is attached. So I actually need something that's a little bit more like squishy in here.
Do you use foam tape ever? That's like my favorite thing for...
Yeah, I think I need to use foam tape, but in this case I wanted something that was like circular. So I think I was using like a rubber gasket or something like that. So this is kind of the fun or frustration of trying to like make your own project on a shoestring budget. It's like you're trying to be like, what's the thing that people use that has this form factor and physical properties, but it's exactly the same as what I'm wanting to use, but not really usually used for this process.
It's hacking.
Yes, that's what hacking is. So I think in here there's like a rubber gasket, and also there is like a round piece of hard plastic that ideally I think of this kind of like sandwich of piezo, right? And the rubber gasket is like flexible in between them. And then there is another piece that's hard, so that when they like smash together, it like impacts, right? And so that piece of hard thing is actually what I have found was like the piece that you can get that covers like screw holes on furniture. So anyway,
Cool.
Yeah, sometimes you can get into like a really long rabbit hole with trying to find these things, but yeah, that's...
Rabbit holes are cool though. They take you to new places.
Yeah, so some discoveries.
Is there anything else you want to jump into before we wrap up?
Yeah, so I wanted to talk about the newest project that I'm working on this year. It's the external lighting for the temple.
Oh yeah, cool.
So there's like two parts of the project. Like one part is the technical piece of it. Like I personally really like the temple design this year. And
is it public? Can you tell us what it looks like?
Oh yeah, the temple design is out.
Oh, okay.
Yeah, but the lighting design, we're still doing some renderings and stuff like that. But I think for me, like it's really exciting and a privilege to kind of be invited by the temple builder to collaborate with him. He has like a bunch of different collaborators all working together. I haven't done any temple projects before, so I don't know if this is the usual thing or not, but that part of it is really interesting. He wants me and the other collaborators to sort of like run the parts of the project. It's almost like an independent project.
Huh.
So the artistic part of it, what I can say now is that I'm inspired by James Turrell.
Oh yeah.
And to me, the way that he works with light is about putting people into an experience that helps them identify the edges of their perception. And so like moving light in a really slow way, and kind of that's sort of the basis of like where the technical or artistic piece of this part of the project comes from. And then the second part of the project that I've taken on is like a fundraising piece. And the fundraising is specifically to pay the stipend of the core team that's working on this. And like it's a little bit new for me, but like this kind of originated from my experiences with working on art and also working as a person of color, a woman of color, like in technology, that often when we talk about something that we value, we don't value everything the same way, right? I went to a women in technology like conference a couple of years ago. I paid like $200 or something like that. And we had 2 days. There was like a pitch competition. There were like 10 companies that were co-founded or founded by like women. And it was really amazing to sit in an auditorium of like maybe 200 women, most of whom are technical. But at the end of the conference, and the award for the pitch competition was like given, there was like $0. And I just think, okay, well, like this is really giving this very like conflicting message, right? We value women founders, but we don't value them with actual resources. We value them with exposure. Right? And doesn't, it sometimes can feel like it's a little bit taboo to talk about because it's difficult to talk about money. But I think in my mind, like artists are sort of treated the same way. Like we value art, we think of it as, a commodity. We think of like the Temple of Burning Man as this amazing core part of the Burning Man experience. And I can go on and on about that, but we don't really value the artists that spend the time and the energy to manifest their vision into reality.
Because people think that it's like something you're doing for passion, so you're getting out of it like that good feeling or whatever, maybe. So
right, but the thing is, like, you can do something for passion, but you still need to like eat.
Yeah, you can't pay your rent with passion. Yeah. Right. I mean, anyway.
Yeah. So I think the fundraising is going to be separate from like the other temple fundraising that's going to be for like materials and transportation. Specifically because I want to like take a step, like, you know, put this conversational topic like into the fray in a way so that people talk about what we value, what does value actually mean. I think that for Burning Man has been talking about how to be more inclusive. And if the only way as an artist to be able to contribute is that you already have the personal resources, like a corporate job, to fund you, then so many voices are going to be missing from this conversation.
To be honest, that's a big part of my feelings about Burning Man, actually, is like it's this radically inclusive environment, but at the same time there's this kind of like de facto division just based on reality, you know, like who can go, who can afford to go, who can take time off, especially like 1 to 2 weeks and stuff. And like it's definitely a part of the culture that isn't really talked about.
Yeah, yeah, absolutely. And there was like an article recently about kind of like Burning Man decommodifies everything except for labor. I think it's a good article to kind of go read, and I think this kind of flows into it, especially for you know, not just the labor of like preparing logistics, but also the labor of actually being an artist and doing like, you know, the creative work that's necessary to bring the magic, right? And
there are art grants, but at the same time that might not cover everything.
Yeah, no, absolutely not. Like even for the temple itself, right? Like I didn't understand this until I was talking with the temple builder, right? And what I told him was that you know, as much as I loved contributing like my engineering expertise, the previous year, like as a consultant, I can't afford to do this, right? I need to go get a corporate job. I don't really want to go get a corporate job, but I would need to go get a corporate job in order to be able to afford to like make art and contribute. And so I think this is my doing the fundraising and like working on this message and getting people to talk about it is my way of like taking a little tiny step forward of saying like, you know, let's discuss it. Let's not just hide it away, because we really need to, if we really value something, we need to value the people who are doing it, and we need to value it with real resources like money, dollars, instead of just exposure.
Yeah, right? That's really cool.
Yeah.
Thank you so much for talking about that. And in general, thank you for coming in.
Sure.
Mingjing Huang, everybody. So cool. Yay. Thank you so much.
Yeah. Follow me on Instagram.
Yeah. And check out her Redbubble. Yeah. On Instagram, once again, it is... oh, yeah. You were saying Playa Yomigae and Yomigae.
Oh, yeah. So Yomigae is the name of the lighting project. And it is a Japanese word that means reawaken. And I think this Instagram account, I started it as a way of communicating the artistic process that, you know, it just doesn't like spring out of nowhere. Like it takes lots of time and lots of work by a team of dedicated people to like bring it to the playa or the real world.
Awesome.
Whichever you count that. So you can follow my progress on my Instagram. Yeah.
And then also your website is essenceengineering.com.
Yeah, that's right.
You can see all these cool pictures of design files and stuff.